How are you, my friends? Let's continue Algebra Course lectures. This is lecture number 19, the graphs of equations, X and Y intercepts. If you want to see other lectures, please, you can visit the playlist called Algebra Course Lectures. Now, in this lecture, we go to see intercepts. There are X intercepts and Y intercepts, if there is any, graphing the equations, and we study symmetry. So, what is a graph of an equation? If you have an equation like y equal x squared minus 4, then at the end here we can see the graph is the set of all points. So the graph is a point, x and y. So I can take any x in the domain here, replace it in the equation, I get y. So every time I get a point xy, the point satisfies the equation. So if I get any point, let's say 2, 7, 0, 1, 5, 2, if it satisfies the equation, that means if I replace x and y, the right side should be equal to the left side. This is what satisfies means. Now, one important thing, we have to know the word on. If there is a point on the graph, the point here, the coordinates, the x and y, they will satisfy the equation. So if I say a point is on the graph, I can replace x and y in the equation. Let's see very nice example 1. Find k if the point minus 3, 2k minus 1 is on the graph of this equation. See, this is an equation that has a certain graph. You don't have to know the graph. It's not easy to graph it so far in algebra in lecture 19. Maybe you'll be able to graph it later, lecture 50 maybe or something. Now, we have a point here, minus 3, 2k minus 1. I need k, so I just say the point is on, so I can take minus 3 for the x here, I put in the x, and 2k minus 1 in the y. That's the whole idea. I will explain it again. The point lies on the graph. The coordinates of the points, the point here given, satisfy the equation. This is x and y, we call them coordinates. So I put in the y here, 2k minus 1 in the bracket. I put in the x minus 3 squared, you see squared here, plus 1, 75 minus 5, and x is minus 3. Just multiply here, minus 3 squared in the bracket, 9 plus 1, 10. So, and this is 75 plus 15. Now you can divide by 10. So 2k minus 1 is equal 9, k will be 5. Let's define now intercepts. There are two types of the intercepts, X-intercept and Y-intercept. X-intercept is the value or values of the x where the graph intersects the x-axis. There can be one X-intercept, or 2, or 5, or 7, or 6, or infinity, or no X-intercept sometimes. Now, easy way to find X-intercept, you can see here, let y equal 0 in the equation, then solve for x. So easy. You don't have to see the graph, you don't have to graph it. So we use X-intercept and Y-intercept to graph. Unless you have a graph is already there, you can look at the points on the x-axis where the graph intersects the x-axis. Now, Y-intercept is the same idea. Y-intercept, the value or values of the y where the graph intersects the y-axis, you see here. Now, in any point in the y-axis, x is 0. That's why we say to find y-intercept, let x equal 0, then solve for y. Again here, any point on the x-axis, any point, y should be 0. Like here, 1, 0, 5, 0, minus 2, 0, whatever, hidden. Now find x-intercept, find y-intercept with these two equations. The first one is easy. We take the first equation, this one here, x-intercept, let y equal 0 directly. You don't have to graph it. I just put the graph here as an extra stuff to understand the idea. Let y equal 0. Here directly we put y equals 0. And now this is 0. 3x over 4 is equal to 3. Multiply by 4. So that's 12 divided by 3. X will be 4. So x-intercept 4, 0. Just 4, 0 here. Y-intercept, let x equal 0. Just put x here, there. X equals 0. Multiply by minus 2. So y will be minus 6. We write 0, minus 6. Only I put this line here, the graph of the equation, just to understand the idea. If you want, you can try this one by yourself. Pause the video and then you can check the solution. If you want. Ready? Let's go. Now this one, example 2, part 2, to find x-intercept, let y equal 0. See, put y equals 0, then I have x squared is equal to 4. So x will be 2 or minus 2. So I can see, I can visualize, I can imagine there are two x-intercept. We call this graph parabola here, x squared. Y-intercept, put x equals 0, and then y will be minus 4. Easy to see here. So 0 minus 4 is the y-intercept. Now, graphing an equation by plotting points. If I give you any equation, usually simple equations, to graph it, step number 1, find x-intercept, find y-intercept if there is any, because they will help you to see how the graph will look like. Find as many additional points as needed. So how do you find the points? Take any x you like from the domain of the equation and then put it in the equation, do find y. Or you can make table. Sometimes in school we're making a table of values, x and y, plot all the points and connect the points with a smooth curve or line. Let's see two examples here. Example 3a and b. 2x plus y is equal to 6. I will try to give you a hint here. When you look at the equation, try, not always, but try to visualize or imagine or think, how does the graph will look like? Because here the power is 1 on the x, the power is 1 on the y, so this is a straight line, we know that. So you can just accumulate all this information about graphs. Y equals absolute value, so it looks like, because these are linear here, it's like a V shape. So let's see the first one. So I know this is a straight line from the power, exponent is 1 on each x and y. Find x-intercept, we did one example, let y equal 0. 0 is there, this is the equation here, I wrote the equation for you. So x will be 3, so I can put 3, 0 there. Y-intercept, put x equals 0. So y will be 6, 0, 6. If you have a straight line, usually 2 points are enough because 2 points will determine the line. So you just draw the line. That's the graph. You want to draw the second one, please? Y equals absolute value of x minus 4. So this is a V shape where we have absolute value on the x. Absolute value of x minus 4 is equal to y. This is the B part. Now let's find x-intercept. Let y equal 0. Put y equals 0, the absolute value of x minus 4 is equal to 0, which means x will be 4. So I have the blue point here, 4, 0. Just be careful now. Let's find y-intercept. Let x equal 0. I put x equals 0, absolute value of minus 4, we know it is 4, so 0, 4. Now look at the blue points. Is this enough to graph the final graph for this? If you join these points, if you continue down, that's wrong because we have absolute value. It's not only a straight line, it's a V shape. Now, when you have something like this, you have to use extra points, or we call it additional points. Additional points, see this point here, 4, I can take one value before 4. So you can take 1 or 2, minus 1, minus 10. I took minus 1 here. Replace it in the equation here, minus 1, minus 4. Absolute value of minus 5 is 5. See, the minus 1 is 5. This is the red one here. This is extra. See, now that means we can continue here. Let me take something After 4, I can take 6, 7, 10, 50, whatever. I took 6 here. Y equal absolute value, put here in the x 6 minus 4, which is 2. So 6 is the x and 2. So 6 here goes to 2, not down. So that's why I continue here dv. If you take any other point, it will be on this line. So the final graph is V shape. Now let's see symmetry. This is very nice property about the graphs. We have 3 kinds of symmetry. The first one, I put here an example in the graph. We call this graph is symmetric with respect to y-axis. Because if you have any point here, xy, any point, 2, 3, 1, 5, then you can find another point minus xy. See, if this is 2, 3, suppose this is 2, 3, this will be minus 2, 3 on the same graph. That means the y-axis will cut the graph into 2 pieces, equal pieces. So we call the equation is symmetric, or the graph also is symmetric with respect to y-axis. Now, how do you check it? Look at the nice, easy way. Replace x by minus x. You see this x? We replace by minus x in the equation, and we see if we get the same equation again. We will explain now in an example. Let me explain the x-axis. The graph here is symmetric with respect to the x-axis. If we have any point xy on the graph, then there is another point x minus y on the graph. So to check the symmetry about x-axis, we replace y by minus y. That's 2 types. I will see the third one after a few minutes. Let's take an example here. Test the symmetry with respect to means WRT. We can make abbreviation here. Test the symmetry according to x-axis and y-axis. I have two equations here actually. Y equals x squared plus 4. So let me show you everything in details. Y equals x squared plus 4. Let's check the symmetry on the x-axis, symmetry on the y-axis. In the x-axis, I have mentioned, replace y by minus y. In the equation, you see directly y, put minus y. X squared plus 4. Multiply with minus because I need to check, is the equation after I put minus y the same? If you multiply with minus, you get y equals minus x squared minus 4. Not equivalent to this, you see? This is the given, this is the given up. This is after symmetry checking, minus x squared, not equivalent. So the equation is not symmetric. If you graph it, it is not symmetric with respect to x-axis. Now let's check the y-axis. Replace x by minus x. So I put here minus x in the x. Square it, you get the same value. So that's equivalent. Equivalent means we get the same equation as the given. So the equation is symmetric with respect to the y. See, without graphing, you can check. You want to try the second one, B part? X squared plus y squared is equal to 16. Check it, please. This one. Check the symmetry with respect to the x-axis. Replace y by minus y. See this y here, I put minus y. When you square it, you get x squared plus y squared is equal to 16. You get back the same equation, so that's equivalent. So the equation, yes, is symmetric with respect to the x-axis. So when you graph this, it is symmetric with respect to the x-axis. Now, checking the y-axis, replace x by minus x. Always you can do that. So x, you put it here, minus x, square it, you get x squared plus y squared is equal to 16. Now, this is the third type of symmetry. Symmetry with respect to the origin. Look at this nice graph. If you have any point xy on the graph, then it happened that another point minus x minus y on the same graph. That means the point of the origin here, 0, 0, is the midpoint between these 2 points. So if you have here 1, 4, minus 1, minus 4. If we have here half 7, this is minus half, minus 7 on the same graph. How do we check? Easy. Replace x by minus x and y by minus y at the same time. In the equation at the same time. Remember before we were checking x-axis, y-axis. Here we are checking according to the with respect to the origin, the symmetry. So look at this nice example. Is the graph of this symmetric? Y equal x cubed minus 10x, symmetric with respect to the origin. Now you can check also x-axis and y-axis if you like. Now this is the equation. You study symmetry with respect to the origin. Replace x by minus x, y by minus y at the same time. Remember, minus y is there, minus x is there cubed, minus 10, minus x is there, and then you have to simplify it. Leave minus y, minus x cubed is minus x cubed. You know, it's minus x minus x minus x plus 10x. Now let's multiply with minus 1 here. So we get y equals x cubed minus 10x if you multiply with minus. Is this the same as this yellow? Yes. So that means when you graph this one later in algebra course, y equals x cubed minus 10x, not easy to graph now. The equation is symmetric with respect to the origin. Now that's a nice question here, example number 6, very important question, VIQ. Study the 3 types of symmetry. Study 3 types of the symmetry. X squared plus absolute value x plus y cubed is equal to 5. Let's see the symmetry on the x, the symmetry on the y-axis, and the symmetry on the origin. Now let's start. One slide on x-axis and y-axis, and one slide on the origin. X-axis I have mentioned before, replace y by minus y. So I have here x squared, I don't touch it. X inside the absolute value minus y, the cube. So it becomes x minus y cubed is equal to absolute value. So the absolute value, we cannot do anything there. We have no conditions on x and y. So it is not the same, not equivalent. So not symmetric on the x-axis. Easy. Let's see the y-axis. Replace x by minus x. So this is a minus x here under the squared here. Minus x inside the absolute value. This becomes x squared. And there is minus x here. Y cubed is equal to 5. This one not the same, you see? Not equivalent, not symmetric with respect to the y. Let's see the origin. So nice, this one here. Origin means replace both x by minus x, y by minus y. Both, all of them. See x here minus squared, minus the x plus, minus the y cubed. Now this one becomes a squared, okay, easy. Minus x there in the absolute value, and then minus y cubed. So it's minus y, minus y, minus y, minus y cubed. I take a minus common factor inside the absolute value, you see? So the minus 1 is a here. We have seen this in algebra course number 1 or number 2. This one here, the minus 1 is the a. And x plus y cubed, all of this is the b. So if you have absolute value of the product of 2 numbers, you can split the absolute value. So multiply the absolute value of a, absolute value of b. So this becomes absolute value of the minus 1, which is 1. And this is absolute value of x plus y cubed. We cannot simplify. So this one is the same, you see, because absolute value of minus 1 is only 1. So yes, the equation is symmetric with respect to the origin. Now, this topic is to be continued in Algebra Course Lecture 20. So 19 and 20 are the same topic. We talk about circles. Now, thank you for watching. If you like the video, you can share, subscribe, and then just to remind you that this is lecture 19 in the algebra course. Thank you very much.